All right, what's up, everybody? Welcome back in. We're going to be talking about isosceles and equilateral triangles. So if I zoom out here, it's this one, isosceles and equilateral triangles. So first of all, an isosceles triangle where there are at least two sides that are congruent. So if I look here, that would be this side and this side. Okay, I went ahead and labeled everything, but let me go ahead and give you the explanations. These two legs, if I were to draw them out all the way up here and here, they meet at a thing called the vertex angle. Okay, that vertex angle doesn't really tell me much about the rest of the triangle. It just infers to me that that one is the non-congruent angle. All right, and finally, the other missing side would be my base. All right, where the legs meet the base, we call my base angles. Those things are special. The base angles are actually the same. Okay, they're congruent. That's the really cool thing about isosceles triangles is that if I'm able to identify the two legs where they meet the base, those two angles are congruent. So that's kind of my theorem right here. If two sides of a triangle are congruent, then the base angles are congruent. So for example here, AC is congruent to BC. Therefore, it tells me that wherever they meet the base, which is right here and here, those angles are also congruent. Okay? This is what we're going to be doing a lot today, is identifying the things that we have. These are my if-then statements. Okay? On letter A, your ifs should always be what congruency it's giving you. So for example, on this one, it's giving me these two congruency marks here. So what are those two congruency marks? Well, they're sides. And the way that we describe sides is with two letters with that line on top of it. AB is congruent to BC here. All right? Now, where the two legs meet is called my vertex angle. Here, the vertex angle is at B. That's where the two legs are meeting. It is not that angle that is congruent. It would be where it's meeting the base, which is at angle C and angle A. Those two things are congruent because it's where my legs meet the base. Now, once again, I will say if this one's 45 and we know what congruency means, this one would also be 45 degrees. Okay? Next one. Okay, what is it giving me here? That's my if statement. My then is what can I infer from that? But it's giving me these two sides. That's CB and CA. Okay? If those two legs are congruent, it tells me something about the base angle. And remember, the base angles are where the two sides meet the base. So here that's at angle B and at angle A. If angle B is 57, what is angle A also going to be? 57. Lastly, letter C. Here's my leg right here and my leg right here. That is my if statement. It's giving me those two things. That's AB and that's AC, which is something the school needs to get, is a new AC. All right, where the legs meet my base, that tells me something fancy about those two angles, and that's that they are congruent. So if angle C is 79, it tells me something special about angle B. It's also 79 degrees. All right, notice how it never relates back to that vertex angle. It's only relating congruency back to just the base angles. Now the converse is true. Converse, no, it's not the shoe. Converse means the opposite is true. You don't need to X that out. I'm just telling you that those two things are the same. So let me go ahead and erase that. If the base angles are congruent, so if it's giving me two congruent angles, for example, that would be like this one and this one. If angle A is congruent to angle B, then it tells me the sides opposite to those angles are also congruent. So a side opposite would be the ones that are directly across. So the one that's directly across from A would be BC, and the one that's directly across from B would be AC. So if it's giving you two sides that are congruent, it can tell me that I know that the two base angles are congruent. The converse is also true. If it's giving me two angles that are congruent, I can infer that the two sides are also congruent. Letter A, here we go. It's giving me my if statement, or angles A and angles B. They both have the same arc length. It's just one, okay? with that in mind, I know that if that's true for any triangle, then the sides opposite to those are also congruent. So that one and that one. So that would be AC and BC. Same thing over here. It's giving me these two arc lengths are congruent. So that would be angle B and angle C. Remember, your if statement is what congruency it is giving you in the image. You can infer that the sides across from these two congruent angles are also congruent. So that would be AB, and that would also be AC. All right? Moving on. Letter A here. First of all, I want you guys to pause the video and see how many triangles you see here. How many triangles do you see? If you got 6, great job. And if you said that this is a triangle, I'm mad, all right? It's 6. You got the big one, you got this little one, that little one, that little one, this one, and that one. All right, fun little exercise. When we have a whole bunch of little shapes within this big shape, we have to really identify which triangle we're looking at. It's not always going to be just this one, or just this one, or one of the 6. We have to identify which specific one we are working with here. So let's look at my statement it's giving me. That's if AE is congruent to DE. So that would be this leg and this leg. If I were to pick a base that connects these legs together, that would have to be AD. It wouldn't be AB. It doesn't make it all the way over here, right? So that would be AD. So we're looking at this whole triangle. All right. Knowing that's the case, if those two things are congruent, what does it tell me about the base angles? They're also congruent. And where are they at? Angle A and angle D. EDC, that's this one, EDC, is congruent to angle CED. That's this one. All right, so obviously I can tell which triangle I'm working with, and it's this one right here. All right. If that's the case, and if I know that two angles are congruent to each other, it can tell me something about the sides that are across from them. That would be CE and EC, and those are also congruent. If AB, tick mark, and EB, tick mark, are congruent, so that's these two legs, the only line that connects them to here is AE, so we're working with that triangle right there. And what do the two legs tell me about the angles? A and angle E. Well, it's that they're also congruent. Lastly, if EBC, which is this one, is congruent to ECB, which is this one, so we can tell we're looking at this middle triangle here. That angle and that angle are given to me. I know that the sides across from them are also congruent. So that would be BE and CE. Feel free to pause the video and look at those if you want again. All right, real quick, before we jump into anything else, let's review what an equilateral triangle is. And if an equilateral triangle is equilateral, so if I have all three of these sides that are the same, it tells me that all three of the angles are also the same. These are linked. And the vice versa is also true. If I know that all the angles are the same, it tells me that all these sides are the same. It works both ways. And the only way in which all of these angles can be equal to each other is if each of them is 60 degrees. All right, knowing all this information that we've learned, let's start applying it with some algebra. So first, if I were to ask you what the if statement is here, I can see that I am given 3 arc lengths, which means that all 3 of these angles are congruent. What do we know about triangles that have 3 angles that are congruent? Well, we know that it's equilateral. And equilateral triangles also have all of the sides are congruent. And if it's asking me to find x, and I already know that one of the sides is 8, that tells me that x is also 8. So with this one. How about letter B? Well, it's giving me, if my if statement was asked, it's giving me these two legs. Okay? Here would be my base. What do the two legs of an isosceles triangle tell me about the base angles? This and this. It tells me that these two are congruent. So if this one is 65, then that tells me that x is also 65. It's an old triangle. How about letter C? It's the exact same shape, and it's given me some work already. I know that this one's 65, and then this one is 65. It's the exact same thing. And now, what do I know about a triangle and all of its angles if I have two and need to find the third? We learned this in 10.1. You just subtract 180 for the other two angles to find that missing x. So here, 180 minus 65 gives me x is 50 degrees. Once again, these two shapes are the same. That's how I knew that that was 65, all right? Next, here we go. It's giving me my if statement. These two angles are congruent. When I know that it's giving me two congruent angles, it tells me what about the sides across from them? That they are also congruent. So if this one is x and this one is 7, I know that those two are the same. So x is 7. It looks kind of like a face, doesn't it? All right, letter E, here we go. Oh, it's giving me some arc lengths here. This arc length and this arc length. I know that if it's giving me two arc lengths, the sides across from them are congruent. So here in that case, if this one's 9, then x must also be 9. Letter F, here we go. This one's a little bit trickier. I have two legs. And I know that the two legs meet at the vertex angle. And the vertex angle, I am not worried about with congruency. I can't tell anything about this yet. Nothing. But I do know something about the base angles, which would be this one and this one. If this one's 47, then that one over here must also be 47 degrees. Now that I have two angles, and I can find this missing x by using that rule that we've applied before, where if I have two, I can subtract them from 180 to find the missing angle, which would be 86 degrees here. It's not as easy as this every time, guys. Just make sure that you are applying the rule instead of just following a pattern. Okay? Letter G, here we go. I have a leg and another leg. The two legs tell me something about the base angles. And the base angles are right here and here. They're congruent. If this one is x, what would this one also have to be? That's correct. It's x. Now what do? I can't do the 180 minus x, obviously, right? And I can't do what we did before. So what I'm going to have to do is set up the triangle sum theorem, where I add them all together to equal 180 and solve an equation. X plus x is 2x minus 38. 2x equals 142. X equals 71. So both of those angles equal 71 degrees. And lastly, obviously, is 11. All right, if you guys have questions and if you need to go through and maybe double check your work, see some things, here, go ahead and feel free to pause the video here. Or pause the video here. Here. Or here to get all that information in. Feel free to reach out if you guys have questions. Good luck. You guys got that worksheet to get on.